we are going to use a pair of mutually orthogonal Latin squares of order 3 to encode this following message here using Olderogge's method. I don't know if that's how you say it, but that's how I'm going to say it. First thing we've got to do is create an array using these things, which I'm going to call M. This array is probably the easier part of this. The second array is a bit trickier. For the first array, what we're going to do is we're going to split this into 3 groups of 3, and we split it into groups of 3 because the order is 3. So this is usually the information bits is usually the order squared, so 3 squared. So the way we do this is we're going to just arrange them like so. Okay, and what we then do is we calculate the total of each column and each row under modulo 2, obviously binary. So we go 1 plus 0 is 1, 1 plus 0 plus 1 is 2, which is equivalent to 0, and same thing here. We're going to do exactly the same thing with the rows. This row's total is 3, which is 1 in binary, and this row's total is 1, and this row's total is also 1. And so that's our first array. The second array, which I'll call n, we need to use these 2 Latin squares in order to do that. So in the first position, we are going to use these 2 as a kind of row and column coordinate to tell me where I'm going to put that. So if I just call these rows 0, 1, 2 and these columns 0, 1, 2, just because this might get a bit confusing. In the first place of my array n, I'm going to choose whatever number is in the 0th row and the 0th column, which is this one here. So I'm going to go ahead and put a 1. In the next place, I'm going to go to the first row and the second column, and I'm going to put whatever's there. So first row, second column is here. So again, we've got a 1. Now our final number in the top row of this array is the second row, the first column, which is this one here. So there's my first row. Let's move on to the second row. We've got whatever's in the first row and the first column, which is this 0 here. Next is the second row, 0th column, which is this 0 here, and 0, 2, 0th row, second column, a 1. And let's keep going. Row 2, column 2 is this 0 here, and 0th row, first column is there, this one here, and finally first row, 0th column is this 0 here. Okay. Nice little check. All we've done really is rearrange them. We have 5 1s and 4 0s. In this case they look exactly the same. I think that is purely coincidence. So I'm going to go ahead and calculate the row and column sums exactly the same way. So I can just use this one for this actually, because they happen to be the same. That's all the work done. Now we just need to know how to encode the message. The way we do that is we start with the message, so 1 1 1 0 0 1 0 1 0, and then we go in this specific order. It is these parity bits is what they are called here, so 1 1 1, these ones, then the column on n, then the row on n. And using this method, we have 1 extra parity bit on the end. So for every of these you've got, so I think it's 3 squared, you would have 4 lots of 3 parity bits plus a 1 on the end, and that 1 is either going to be a 0 or 1, depending on what makes this code word have an even weight. So we've got 1 2 3 4 5 6 7 8 9 10 11 12 13. It's an odd weight, so we put a 1 on the end. If that was an even weight, we would have put a 0 there. And that is our encoded message using Olderogge's method.